Hello friends, this video on Ray Optics Part 5 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 4 before going ahead with Part 5. Now let us talk about the focal length of a spherical mirror. So right now we are studying all the terms and all the concepts related to a spherical mirror. Only after that we will talk about how reflection takes place in a spherical mirror. So what is focal length of a spherical mirror? So till now we understood what is principal focus, right? So focal length is nothing but the distance of the principal focus from the pole of the mirror. For example, let us consider the case of concave mirror. We saw that in case of a concave mirror, this is how the principal focus was. This is the principal focus, right? And this is the pole of the mirror. So what is focal length? The distance between the focus and the pole. So this is my focal length, right? This distance would be the focal length. Now similarly, in case of a convex mirror, what happens in case of a convex mirror? This is my principal focus. So the distance of the focus from the pole, that means this distance is your focal length. So focal length is generally denoted by a small f. So please remember these these letters which we use to denote these terms, because that will also help you, because everywhere we will use the same abbreviations. For example, for focal length we will use a small f. For principal focus we use a capital F. For pole we use a capital P. So please get used to all these abbreviations. Now we will look at the relationship between focal length and radius of curvature. So I explained both the things. So do you remember what is focal length? Focal length is nothing but the distance from the principal focus to the pole, that is small f. And what is radius of curvature? It is nothing but the radius of the sphere of which the mirror is a part. So this is capital R. So we will find out a relationship between this focal length and radius of curvature. So this is a very important relationship actually. So what is this radius of curvature? It is nothing but, you can see that, for example, let me consider your concave mirror. This is the concave mirror. Let us suppose this is pole. Let us say this is my principal focus and this is the center of curvature. So that means this distance is the radius of curvature and this distance is the focal length. So we want to find out a relationship between this focal length and this radius of curvature, right? You got a better idea now that what are we trying to do? So now in order to derive a relationship between R and F, let us consider this spherical mirror. Let us suppose we have a concave mirror and this is the pole of the mirror. This is the principal focus and this is the center of curvature. Let us suppose, and this is my principal axis of course, right? So let us suppose there is a ray of light which is incident on the mirror parallel to the principal axis. So what happens after reflection? It passes through the principal focus, because we saw in our previous slides, right, that the rays of light which were parallel to the principal axis, when they fall on the mirror after reflection, they all met at the principal focus. So we can say that this ray of light which is parallel to principal axis, when it falls on the mirror, it gets reflected and passes through the principal focus, right? Let us say that this ray makes an angle, for example, say 2 theta. So if this angle is 2 theta, this entire angle will also be 2 theta, correct? Okay, so now let us name these points. Let us call this point as A. Let us draw or complete this triangle. Let us call this point as B. So now if you look at the triangle, if you look at this triangle ABF, what do you see? You see tan 2 theta is equal to AB divided by BF, because tan theta is equal to perpendicular by base So in this triangle, you see perpendicular is AB and base is BF. So you can write like this. Now, since we have to involve, so we want to find out a relationship between focal length, which is this F, and radius of curvature, which is this R, right? So we have to involve this length as well. So let us draw, or let us join this point C with this point A. So what happens, this entire angle was 2 theta. So now this is theta and again this is theta, right? So now let us consider this triangle. So if we consider, so if this angle is theta, what would be this angle? Because you see this is also theta, so this theta and this theta are alternate angles, right? This theta and this theta, they are alternate angles. So this is also theta. So now let us consider triangle ABC. So in triangle ABC, you can say tan theta is equal to perpendicular, that is AB, divided by base, that is BC. Right? Now here in this case, we can see that theta is a very small angle, right? Because right now we are talking about the angle which the ray of light is making when it falls on a mirror. So these angles are all small angles. Now when theta is very small means that the incident ray is making small angle with the principal axis, right? So if theta is very small, in that case, we can say that tan theta can be written as theta, right? Similarly, tan 2 theta can be written as 2 theta. So what happens to these two equations? So you can write these two equations like this. You can say that 2 theta is equal to AB by BF and theta is equal to AB by BC. Right? So this is your first equation and this is your second equation. So from these two equations, you can say that AB, from this equation it becomes AB is equal to 2 theta into BF, and from this equation you get AB is equal to theta into BC. That means if you see, the left hand side of both these equations are same, therefore the right hand side should also be equal. So 2 theta into BF should be equal to theta into BC. So this theta and theta will cancel. So 2BF will be equal to BC. Now what is BF? BF is nothing but, see, this B is very close to the pole, that is P. So we assume that BP is very, very small. Since B is very, very close to P, so what do we assume? We assume that BP is extremely small and it can be neglected. Therefore, this BF can be considered as PF, right? So we can say that 2 into F is equal to, what is BC? BC is nothing but PC. So this is equal to R. So that means the radius of curvature is equal to twice the focal length of a spherical mirror. So this is a very important relationship and you will see that it will be used every now and then. So this is true for any spherical mirror. The radius of curvature will always be twice the focal length of the spherical mirror. So you saw that how did we derive this relationship? Right? So now here we have assumed the case of a concave mirror. So instead, if you want, instead of concave mirror, you can consider a convex mirror and derive the same again. The only difference would be that in here, what happened? The ray of light which was incident, it passed through the focus. In that case, the ray of light will get diverged and it will appear to pass through the focus. So I'll just draw it for your reference. In case of convex mirror, in case of a convex mirror, it would be somewhat like this. So a ray of light incident parallel to the principal axis, after reflection it will diverge in this way. But if you extrapolate it, then it will pass through the principal focus. So in this case, we will assume that the angle, so here we assumed that it makes an angle 2 theta. So here also we will assume that it makes an angle 2 theta. So here also we'll do the same thing. We'll consider this triangle, and then again there will be a center of curvature. So we will join it with the center of curvature also. So we'll do the same things as we did in the case of concave mirror, right? So the calculation part will remain the same, just that your ray diagram will change because this is a diverging mirror now, right? So I hope now you will be able to, just for your own practice, you try to derive this expression for a convex mirror as well, right? So I hope it is clear to you now. Okay. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.